Welcome everyone to this first year webinar from the Young Members Group. I see that there are still attendees coming in, but I think we'll just start. My name is Andreas Sjåstad. I'm a proud member of the International Young Members Group Board. At the daily basis, I work as a concrete technologist for a Norwegian contractor. Today, we're so lucky to have Ze'ev and the Young Members Group Israel with us that will share some of the progress that the Young Members Group has made in their country and also some exciting projects that they're working on in Israel. Practicalities, you can ask questions in the chat and we will bring those questions at the end of this meeting. And I think I'll just let Ze'ev introduce himself and his team and we can start from there. Welcome, Ze'ev.
Hi, everyone. Hi, Andreas. Thank you so much for inviting me.
You're welcome.
Thank you very much. So today we're going to talk about YMG Israel and a little about Israel. I don't know if actually anyone knows where Israel is on the map. So we will try to clarify it and walk you through some of the main projects in Israel in the, let's say, last couple of years. We have a short presentation around 45-50 minutes, and afterwards I would be happy to answer any questions. You may write it down in the chat menu. Let's begin. So again, thank you very much for inviting us. My name is Ze'ev Navon, which means wolf in Hebrew, actually. And the lecture is about from internship to partnership through the Israeli construction industry and where it led me after my studying, and where every one of us can actually go from an intern through a team member to maybe a partner in a firm. And it doesn't matter if it's in design construction or construction management or execution. I think it's for the best that we will try to be the best we can and try to do the best work that we were able to. So, a short resume, I studied civil engineering in the Technion. It's in Haifa, the north of Israel. I did my bachelor degree and also my master degree with a thesis in SFRC, in steel fiber and reinforced concrete. And I did a lot of steel design, concrete design through the years in several offices. I have designed over 1 million square meters of structures. I think it's a pretty nice amount of structures and metrage to work at in the last couple of years, the last 6, 7, maybe 8 years. And because Israel won't stop building. So I had the opportunity to take part in it. And I'm a co-founder of the Young Members Group in Israel. We actually established it 2 years ago, almost 2 years ago, and I will discuss it later on. So Israel meets the eye as the Decepticons. ID numbers, this is Israel. All the way to the east side of the Mediterranean Sea. Pretty small country, only 22,000 square kilometers, which is 420 kilometers long, and from 60 to 115 kilometers wide. And almost 70% of it, it's desert on the south. And the current population is 9.3 million. I think it's the 2020 scale. And by 2050, we will rise to about 12 million people. Fun facts about Israel is there's only one big mountain over in the north. We call it Mount Hermon, which is only snowy in the winter, mostly in the winter. one main river, which is the Jordan River, which it's actually the border between Jordan and Israel. And both Jordan and Israel share the lowest place on earth where you just can drive by with your car and walk side by side, minus 400 meters below sea level. It's a pretty interesting place, and we'll talk about it. And of course, the Jerusalem, the old city, the holy city, which probably you all know. Around the Dead Sea, there's a lot of phenomenons because the groundwater is really salty. So there's a lot of deep sinkholes, which actually can occur. And over here, you can see an off-road vehicle who happens to get inside a sinkhole. No one got hurt, fortunately. But unfortunately, the deep sinkholes do make you wonder and copy the roads or off-roads approach near the Dead Sea. We have a lot of types of soils in Israel, from clay with silt, fat silt, rock, sand. All over the beach strip is sandy, of course. In the north, around the Kinneret, which is the top mini ocean and lake, there's a lot of hard rock, okay? And also in Jerusalem, because it's the mountainside. And another interesting fact is Great Rift, which is two tectonic plates who happens to be right below the Jordan River, and they keep on moving around 2-3 millimeters per year, side by side, and you can sense it from Eilat city without tax, so it's a vacation city, all the way through the Jordan and the Dead Sea, and to the north from the Kinneret Lake and to the Mount Hermon. The construction industry in Israel is pretty massive, one might say. It's around 4.5 to 5 billion euros per year in capital. And the vast construction is around accommodation and apartments. Israel increased population in a very, very high rate. So from 55 to 60,000 new apartments per year are delivered to the public. And we are fortunate to live in this beautiful time because there's a lot of structures to be built, a lot of structures and bridges and railways to do the construction about. Over here, you can see a massive raft in Rambam Hospital, also in Haifa. Over here, you can see only half of the raft, but of course, you can see the great excavations with the walls behind it. I would like to talk about the Shalom Meir Tower, which is the eldest tower, eldest high tower in Israel, 34 floors, 123 meters high. It was under construction from 59 till the year 1965. 6 years almost took him to be built. And from 65 till 19, it's the highest building in Israel, and almost 2 decades, I think, was the highest building in the entire Middle East. So from 99, he got replaced by one of the 3 towers of the Azrieli-shaped round tower. 34 years, it was the highest building in Israel. So you can see there were like, let's say 40 or 50 years of, let's say, nap time in the construction industry. And from 99, from the year 2000 until now, 2 decades, that the skyline has changed a lot. Fun fact about the Migdal Shalom, about this tower, is that there wasn't any earthquake code in Israel. And so it got built by the Californian code, which we all know it's pretty severe. And through the year 2003 till 2004, he got renovated, and after an earthquake double check and reverse engineering, they decided to put a pool on the top floor on it. So this should be enough, I guess. We can see the skyline mostly in Tel Aviv and Ramat Gan, which are pretty much in the main section of Israel. We have the Azrieli town, which is 197 meters long, 50 stories. We have Moshe Aviv, which is 70 floors in Ramat Gan. And this circle who got built in 1999, who replaced the tallest building in Israel from the Shalom Meir Tower. All three of these towers on the right side, you can see there's a triangle, a circle, and a rectangle building type of shape. And Azrieli actually is going to build a new one. Over here in the middle is the Sarona Tower, also by Azrieli. And there's another one under construction, 91 floors, 323 high. We call it the Azrieli Spiral Tower, which is under construction right now. And two main buildings or mega tower buildings who are in the design stages right now as we speak. Bein Arim, which means between cities, around 100 stories, 400 meters high. And the 120 tower, which is obviously 120 stories high, which apparently gonna be one of the highest accommodated towers on Earth, because there will be an apartment or maybe an office around 516 meters high. So it's pretty high without any major antenna on top or triangle on top. Bridges-wise, there have been a lot of new construction, a lot of new bridges in Israel in the last few years. Some of them are still bridges, as we can see here. The Yudit Bridge in Tel Aviv was designed by Rokach Ashkenazi. And this is the Kiryat Bridge, also a steel bridge, pretty nice one. And bridges actually won some contests in Europe and worldwide. This is a steel structure bridge in Be'er Sheva, also designed by Rokach Ashkenazi office. You can see there are also many railway bridges and highway bridges, off-road and on-road, concrete bridges by massive pillars. Some of them will rise to 60 meters high and even 90 meters near Jerusalem is long. This is the most famous bridge, I think, in Jerusalem, because it was designed by Calatrava, who we all know, and it's made out of box plate girder from steel, and it uses Jerusalem railway light. Some special projects in Israel in the last years is we call it the Red Line, or Israeli Metro, underneath Tel Aviv and Ramat Gan and Bnei Brak, some main cities. Over here we can see the TBM tunnel. And massive structure to the groundwater behind the walls. In fact, there are 120 centimeters thickness of walls all around the stations. This is a Haifa port, which is artificial island. Over here, a silo for cement industry in Nesher in Ramle. 4 silos designed by Moshe Peer. This is a solar power complex in Shalim, in the southern part of Israel, near Ashalim. It's like a small village, which manufactures around 30 megavolt of power. There are more than 100,000 photovoltaics. And over here, you can see the mirrors who are rotating just to catch the right angle from the sun and all the way through the lighthouse on the top of this amazing concrete structure, which is 240 meters long. As you drive by to the south, it looks like a sun. So become an engineer in Israel. There are some stages, most of them you probably know, regarding the academic institutes and the academic procedure you need to go through a bachelor degree. For soil mechanics and soil engineers, there's a master degree that must to take place. And through the internship process, which is the main process, I think, for the young engineer in Israel. It's formulated by 3 years of internship, which the young engineer will try to get into a firm, which is a renowned firm, who deals with some massive projects and massive design, construction, management. And through the process of years of process, they need to handle previous reports and try to cover the knowledge that they have endured through the process of the internship. And in final, there's an exam, which is a governmental exam with a theoretical section and a practical section that you must pass to be an authorized engineer in Israel. This is me actually, and my friend through the bachelor degree. Even though it was a pretty hard time, we managed to find the time to take a small nap. So the internship process is due to a tight schedule, as we all know, and it doesn't matter where you're at a design firm, construction management, or project management. Every work is pretty demanding. Here in Israel, it's, I don't want to say custom, but actually 45 to 60 working hours per week is pretty common, unfortunately. It's high stress and high volume work, which everyone needs to take. And the fun is that it's actually interesting. And if you are an engineer in Israel, you are able to take part in some massive projects. And due to the fact that in Israel, while you finish your first degree, you can be 27, 28, maybe 30 years of age. Some of my friends have started the bachelor degree married, some of them as parents with children. And it's pretty nice, I guess, that one of your crew members, of your team members or friends are actually old enough so you can trust them. You can hand over the responsibility, and you can be sure that they will do the job on the best side that can be done. And it's pretty nice to see that. Over here, through the internship, you need to do modeling, analysis. We can tech of Be'er Sheva steel bridge made by Shoval Yehudei engineers. And on the lower side, you can see the bridge itself in AutoCAD 3D modeling. We can see what a nice bridge, pretty complex bridge, all through the design procedure. And some different modeling with some different programs or structural analysis programs that we have here in Israel by Atir. Atir is the name of the firm. This is a strap model. And of course, there's Zoom meetings due to COVID, fortunately, but we actually managed to work by it. Here is all the friends from the YMG board, Marta and Vlad, and everyone. So becoming a team leader. I think one of the the most important things as a team leader is to master your expertise. While you work 60 hours a week, that's give or take 230, 240 hours per month. And we all know it takes around 10,000 working hours to master something. So it's pretty common that during the first 3 years of internship, you actually master your expertise. Every minute you spend on working, calculating, doing a static scheme, try to figure out the base model, how the flow chart and the loads going from the roof to through the slabs all the way to the foundation. It's something that you must know by heart. Also through the tasks and schedule and through the teamwork, which I think in Israel it's pretty important, because the vibe through a project procedure is that everyone needs to take part, every voice matter, and it doesn't matter if you are a young engineer or a senior engineer, you can still notice something that will do very good to the project, no matter if it's work-wise or schedule-wise through the procedure of building the project, or budget-wise, of course. You need to know your limits, and you need to know when to ask for help, when to ask for some reinforcement, maybe some counter opinion of another engineer, and it doesn't matter if it's a senior engineer or a freshman engineer. Most of the time it's really important just to hear another opinion and someone to walk you through your project, just to see if there are any mishaps that you haven't noticed. The workload and never stop learning, I think it's one of the most important things that I've learned through my own journey. I started as a young engineer in, let's say, a big firm. I spent there 3 years studying and mastering and designing all kind of nice structures. And two of my colleagues will demonstrate later on some main projects they took. And through this procedure, I know that with the union, the engineering union, the Israeli Association of Construction and Infrastructure Engineers is the place for me to be and to take part and to lead some special projects. And I will introduce you the YMG members of Israel. 3 of us, Gilad on the left side, Shachar in the middle, and myself, are structural engineers. We studied structural engineering, and we actually work in structural engineering firms. Akiva, who may also studied construction engineering, works as a construction lead manager in an execution firm, and he is supervising and leading a really massive project. We call it Ra'anana Park, 90,000 square meters. And Eldad over here is a project manager who happens to be my project manager in one of my projects here in SYE Engineers, a really big and massive project in the south of Israel. Our goals and visions through YMG Israel and through the vision that we try to held in the association, in the Israeli Association, is to elevate the young engineer standing in the common industry. As I said earlier, the young engineer in Israel is a grown man. He can take the responsibility. He knows he can contribute to the process, to the project, and his voice needs to be heard, because each and every one of us has been there and would like to have a better chip with a milestone through the process that can enrich the knowledge of the young engineer. We would like to join Israeli regulation and junior members and observers in Israel, and I figure out that also probably in Europe and the States also, most of the committees are assembled with pretty elderly professors and senior engineers, which most of them past 60 years of age. So we think it's pretty important to take part in these committees, these regulation procedures, and try to make an impact and try to understand what goes through these committees and try to make the best influence we can at this early age. We try to strengthen the relationship with the universities because we know the universities and the academical institutes would like to investigate special things that aren't related to the industry, aren't related to the main problems that we are working through and going day with. It's pretty important to make sure that that today's students know what they're getting themselves into in the years to come. We would like to share the knowledge through multidiscipline online lectures. We call it Project 21, and I will talk about it in a second. We would like to do improving and simplifying the internship process through preparation of a course to the exam, to the professional engineer exam. And with the association, there's a course for every engineer who would like to enlist to this course. We'll help them go through the exam with much more higher rates, which is good. Practical publications and position papers regarding all kind of projects and things that here in Israel, they haven't been updated since the 1960s or the 1970s. Some codes, some regulations, some authority of the engineer, the young engineer and the enlisted engineer, which is pretty complicated, but we are trying to do our best to influence the best we can and to change. Of course, forming a cooperative and widespread community and just to share the knowledge and that we can ask our friends and colleagues and work through problems that maybe one of us or some of us has encountered before. So we won't have to walk through the entire process all over again. And some say it's take the short round. I think it's really nice to hear another opinion, someone you can talk to professionally, someone who can walk you through some stages and the challenges that he gone through in his projects and spreading the word. So through Project 21, that's a really nice project that we work through in Israel, in the YMG. And we call it Project 21 because every Wednesday at 9 p.m. Israel time, there's a lecture made by a young member, or mostly by a young member, in some various topics through design and project management, execution and construction, fire and safety, soil mechanics, through cranes and all kind of really nice lectures. You can see on the right side, it's like pretty grayed out, but you can see some nice topics. And the thing is that we won't stop learning. We won't stop enriching our knowledge. And after you graduate from bachelor or master degree, it doesn't matter, and keep on working on your projects, you feel like sometimes that there's much more that you are missing because you only see the spectrum of your 10, 12, maybe 15 projects that you are dealing with as a young engineer or as a team leader. And through these lectures or webinars, you can share your experience with other engineers made by young engineers through code calculation and some foundation design and tall building design and bridges design, which is great. I believe it's great. There's an average of 180 participants per lecture, and in total, over 5,000 entries to these lectures. I would like to introduce Shachar Rafael, who is also YMG board member, happens to be a dear friend of mine, and he will do a short presentation on a specific topic that he was dealing with. Shachar, be my guest.
Hi everyone, thank you Ze'ev for the introduction, and thank you all for being here tonight. I want to introduce myself as an example of an engineer milestone. I'm not sure I am the common, but it is an example of what an engineer can achieve in such a short time. As you see, I am 35 years old, married with 3 children. I started the university with 1, and between lessons and exam, become a father of 2. I even remember myself coming to lecture with the stroller. From the second year in university, I worked as a site supervisor in Haifa, studio and project, and other project that gave me a lot of experience and knowledge about site point of view, what helped me a lot when I became a structural designer. After graduate, I focused on post-tension elements. I designed hundreds of thousands square meters of post-tension slabs and huge transfer beams that I will show you an example in a few minutes. After 3 years, I became a team leader, and I had the opportunity to work on mega project abroad Israel. Mall in Romania, office and residential project with a 30-story high building in Serbia, projects in Georgia and Poland, and many more projects in Israel. Super tall building like 60 to 90 stories and more. After that, I was assigned to be a chief engineer of the firm. 2 words about the firm. David Engineering is the biggest structural design firm in Israel, with approximately 140 employees, 4 partners, 30 years of experience, and more than 3,000 projects. Many of the high-rise buildings in Israel were designed by the firm. As a chief engineer, I am a member of the board of the firm, and I am in charge on the quality assurance team that deals with the quality of our products inside the office and supervision on sites. I am in charge also on the R&D team, research and development, that we are developing internal softwares to increase our productivity and implement new technologies and products. In this hat, we also involved in the Israeli Standards Institute. I have also a legal department and special analysis that also are under my hands. As you can see, in only a few years, I worked hard, but got plenty of experience that I am not sure that that is familiar in other places around the world. Now, I would like to show you an example of a unique project I was in charge on after only 1 year after graduating. The name of the project, as you can see, is Toha 1, a 29-story building with a very unique shape. The architect is Ron Arad from London. As you can see, the special geometry of the building hiding many structural challenges, starting with 3 cores, as you can see, including inclined columns that breaks in a different angle on different floors, flat slabs, and what I wanted to talk about is 6 transfer beams that carry the 26-story above with columns that transfer loads up to 2,000 tons. Click, please. The difficulties starts when those beams was a major part of the architect vision. Although we needed larger beams, the architect refuses to give us even 30 centimeters more, the original design. As a young engineer, the head of my office and the team leader told me, this is a problem I need to solve and to come with a solution within a week. They gave me the opportunity to figure out a solution by my own. The separate beams, you can see here in the picture, were at the maximum limit of stressing, post-tensioning, but the limit deflection by code hasn't reached yet. The solution I came with was to use the slab between those beams as a box section. The thicker bottom slab, I thicker the bottom slab between the 2 beams. So the thickening was upwards, and the architect didn't care. tensioning the bottom slab, and the most effective thing was to tying the upper part of the beams to the cores at the sides, what gave some continuity and solved the problem. Here you can see the height of the beam with some tendons at the bottom slab. And if you do another click, please. This is also the tensioning of the beam and the bottom slab. And here you can see from above the upper tensioning tie to the core on both sides. Click. Here is the final product, and on the left you can see it while production. And this is the finished product, quite the same as the initial vision. This is an example how to let young engineer to grow, to think, and to find solution out of the box, to take responsibility and to execute the solution. Thanks.
Shachar, thank you very much. It's actually a pretty massive structure and interesting building. And correct me if I'm wrong, I think there's another sibling of this structure who was 80 stories high, right? Yeah, 80 stories high. I would like to share with you some interesting project was held by the Israel Nature and Parks Authority. This is the owner. The site management and contractor is the City of David. And the archaeological supervision by Israel Antiquities Authority, designed and managed by Grushko Engineers, who is the firm that Gilad Fireman, also another YMG board member, works in. And this project, and Gilad itself won the ITA Tunneling Award that was held almost 2 months ago. ITA, as you know, is the International Tunneling Association, and it got to the first place under the category of the oddities of the underground tunnels. I would like to show you a short video, 6 minutes long, of this incredible project, which can showcase the depth and the history of Israel through engineering, through an archaeological point of view. And I would let the video do all the time. Thank you very much.
This road is very special. It brought people together. It was a journey of a lifetime. This is the last part of a fantastic journey, a memorable journey, in fact, a journey that would never be forgotten, of families, people, children, elder people. They gathered in small towns and villages. They came together, and then they began their long trek in convoys up the main roads to Jerusalem. The last lap, the last 600 meters of this journey took place on the pilgrimage roads that we are excavating now.
Let's take a minute to get oriented. In Israel, in the most sacred part of the holy city of Jerusalem, just below the old city, the western wall and the Temple Mount, lies the city of David. At the southernmost tip is the Shiloach pool, and from there, beneath the modern-day road, lies the original thoroughfare upon which pilgrims walked in the Second Temple period. It has been hidden deep underground for over 2,000 years. a project has been revealing the original flagstones of that ancient thoroughfare. The length of the tunnel is about 600 meters, beginning at the Shiloach pool and stretching to the Temple Mount. The illustration gives an image of the ancient Pilgrims Road with the Shiloach pool on an up-to-date aerial photography. The depth of the tunnel varies from tens of centimeters to about 6 meters. We can describe the layers from down to top. The upper rock layer is limestone from the Binah Formation. Above it, the drainage canal in compacted fill that was placed with some stone paving of the road. Above it, archaeological fill, and at the top, modern fill. The archaeological fill is very heterogeneous due to the mixture of stones, soils, and voids. Thus, the soil parameters have a very large variation. The typical section of the tunnel is about 3.5 meters wide, but along the tunnel there are sections with a width of 2.5 to 7 meters. The typical support system is made of steel arcs, IPN 160, every 120 centimeters. At some sections, the support systems was changed to steel frames due to the height limits. A pre-support system of pipe umbrella is installed above the arcs and the frames. The arcs and the frames are based on concrete cast-in-place shallow foundations. At some points, with high loads, mini-piles foundations were installed. The following animation describes the phases of excavation and support. Each excavation round begins with the installation of hand-drilled pipe umbrella pre-support, which ensures the safety of the excavation and limits the settlements at the surface. Following the completion of the pre-support, steel arc is then placed right under the pipes and the concrete foundations are casted in place. Each excavation step, which is 1.2 meters, an additional steel arc is installed. In the spacing between each arc, a thin steel profile is installed, and the gap between the arcs and the surrounding soil is then grouted. The manually excavated soil is finally sent to archaeological classification. Each of the described excavation round is 6 meters, constantly followed by another one.
Towards the end of the Second Temple period, Jerusalem went to war against the great empire of Rome. Thousands of people, fighters, and also civilians that survived, they escaped under the ground into the drainage canal. And we found, under the pilgrimage road, the exact points, 5 points, where the Romans took sledgehammers and broke through the road and entered underneath the ground into the tunnel.
The wall of the drainage channel was missing, and that was an opening which allowed us to basically come from beneath and go above the drainage channel in order to begin the exposure of the street. I remember the first day when we crawled into that little opening in the drainage channel and we began to discover the edge of the street, and we realized what an important moment that was, because it was the moment where we could recreate what happened here 2,000 years ago. There is no other excavation in the world which puts in such an infrastructure. Nothing of this kind can be seen anywhere else.
It was a pleasure to share with you this unique project. We invite you all to visit our project. Thank you for your attention.
Okay, hi, I'm back, and I hope you enjoyed the video. And we will try to upload it maybe later on, so everyone can enjoy it properly. And I would like to talk to you about what the future holds. And over here, we can see the Israeli construction tech, which means an Israeli government decided to help this industry, make it better, make it more secure, and make it more dominant and much more profitable, just to make sure that demands will be met and projects will be set according to the 5 years program and 10 years program and 30 years program by the government till 2030 and 2050, which means that there are several types of tech and innovations. Part of them are the construction tech, as you can see on the left side, and you can see some logos and some main firms which involved one way or another in the construction tech. And on the right side, you can see the property tech, which involves the much more entrepreneur side and aspects of the industry, and also try to collaborate between these two. And some of them are dealing with planning and design, and as you can see on the left side, enhancing on-site execution. Some of them trying to make the execution much more safe. Some of them trying to do a mechanical job where a man-made job is being held in these days. And some of them trying to use artificial intelligence. I know there's a massive project through cranes that has been held and tested here in Israel through all kind of smart mechanical smartphones and smart drones, trying to replace some sort of supervision while drone flying over the high tower, the main tower, through edges. You can see there's some sightseeing, and I'm happy to invite you to Israel through the Israeli Association of Construction and Infrastructure Engineers. We would be more than happy to show you around and show you around some of the main projects, some of the nice projects that we've seen during this presentation. And of course, only a short presentation which can be a showcase around 1% of the struggles and the projects being held right now. I would like to shout out to you all and send my best gratitude again to the field organization through you guys and the worldwide community. And I think we can reach very nice places together as long as we'll keep in touch, ask another, maybe some help, maybe for an opinion or some tips regarding the massive projects that we're dealing with. And I'm sure that you all need a hand every now and then, and we would like to take part in it. And so thank you very much. And I would be honored to answer any questions if there are none. And thank you very much.
Thank you so much, Ze'ev. It's been great to listen to you, and it's very exciting that all the projects that you have, and really impressive educational focus, and you strive very hard to get good work and good work ethics for all your students. Yeah. We have some few questions here. He's still writing it, but do you feel that engineering is a popular way to go in Israel, and are they prepared for all the work that is required of them?
I think it's pretty popular because I like my job, and I try to make sure that everyone knows that I like the job, and also my fellow. I think in the past decades, I've been trying to shift its dedication and focus from high tech. We once called it the high tech nation, and from startup nation, and through engineering and engineering high tech solutions, because industry is industry, and seen before 4.5 to 5 billion euros per year in capita. And I think there are many solutions and many collaborations between the high-tech nation and between software solutions to this industry. So in Israel, you have around 600 to 700 graduates per year in the engineering bachelor degree. And I guess pretty much the same, or a bit less, around 450 to 600 people who are graduating from college, who are like practical engineers. But still, we're missing around 2,000 engineers per year.
Yeah. We have a question from Abdullah Al-Darfan. You mentioned lecture by young members. Is it online? Can I join as a student in a different university?
Yeah, sure. Most of the lectures, all of the lectures are online due to COVID, unfortunately. And most of the lectures are in Hebrew. And we talked about in the YMG board meetings about doing some webinars in English, and we're working on it. And I'm sure that very soon there will be some interesting webinars from the YMG Israel guys and girls, and for you to join. That's Wednesday night, 9 p.m. Israel time, 8 p.m. Amsterdam.
Yeah. And I guess that you will still continue to work or to arrange the weekly webinars in Hebrew, but maybe we can have some joint sessions where, like today, that
Sure.
You have a presentation in English that we can also have partake of.
Yeah, sure.
Question from Stefan Perek. Which project in Serbia was he engaged in? Maybe it was
Skyline.
Skyline.
Belgrade and Airport City Belgrade.
Okay, yeah. And for those of you that are not that familiar with the Young Members Group internationally, you can go to the FIB International on the website, and you can find the Young Members Group there and read more about what we do internationally. We try to be a sort of a network of young members group from different countries and try to network and coordinate some of the work that we can collaborate on and share. And hopefully in the future we can meet, because we try to engage people all around the world and try to get people to be a part of something bigger that is in the international arena.
For sure.
We have a question from Arle Louis Libed. He's a student from the Philippines. I took this webinar as part of our OJT course. I just want to ask if we will get a copy of this recording and a certificate. Yes, I think we will be posting this session on YouTube. And I think that you can find information on that on the social media, or just go to YouTube and type in FIB International, and then you will find all the previous recordings that we've had. And when you signed up for this course, there was also a information about if you want a certificate that requires the Secretariat to actually put in some work in actually writing those. So I think it's 10 euros to get the actual certificate. But you can check it out on the FIB International website on the link for today's event. Yes, and there's a new question from Abdullah. Israel has different types of soil, clay, rock, sand, and silt. In your experience, which type is the hardest to deal with?
Oh, that's a nice question. I think every soil that around and involves deep water and groundwater is much more complicated. And we have like, we call it fat clay, which changes its volume through the periodical year from winter to summer. And there are pretty massive section in the southern part of Israel where the clay is very massive. You have to drill some really, really long piles just to reach a firm layer which you can anchor the structure to it. And I think the problem is not with the monsters and the awesome and great and big scale structures, but the main problem is with the medium ones and the small ones, because they are the ones that the influence and the change of character in the soil really affects them as much. So you really need to design the pile correctly, not in the number of piles and lowering the capacity and everyone, because the earth moves and shifts the piles up and down in the periodical segments. So it's really fickle.
Yeah, soil can be hard to work with. Is there any other questions? We try to keep these webinars for 1 hour or 1.5 hours. So it's now been exactly 1 hour. And there's one more question or two. The first one from Stefan: which kind of codes do you use in Israel?
Sorry, which kind of what?
Code, the building codes.
Yeah, we have the Israeli code, and originally relies on the British standard, and mostly in steel structures, and we're now embracing the Eurocode from 2010. And there's a working group on an Israeli annex, but it's still a work in progress because the Israeli code authority it's a pretty complex one. So we have several of codes of Israeli code that are every couple of years being dated, and most of them are on the British standard, and then the last few years on the Eurocode, based on the Eurocode.
That's good.
Yeah.
It's good that you can join us in the work for the Eurocode. And
yeah, there are some differences with the key factors and the safety factors. Pretty much the same. I think the Israeli code is much more simple to work with. Most of the time, and I'm being cautious, most of the time is conservative. But you really need to know what you're doing and what you're calculating, because we already found some misdemeanors issues between the two codes.
A new one: which seismic zone do Israel lie in?
Yeah.
Earthquake.
Yeah. Actually, I would like to go back for a second, because I think we passed by some interesting slide that maybe we ran over. Over here, there's the two tectonical plates, and over here, this section is pretty severe in the properties of the seismic design, and we call it the Z factor, which is the gravitational earth moving factor, and which can be 4 and 5 times much more severe than in Jerusalem or Tel Aviv. Over here it's 0.24, while in Israel and Jerusalem it's 0.07 or 0.06. And the structural design in this region needs to be with some demanding details and much more, how do you say, ductile behavior of the structure to be maintained.
Abdullah says he's interested in structural design and construction management as well. Can work in each from time to time?
Yeah, sure. You can.
Yeah.
I think the best way, and it's the most common way, at least here in Israel, with my colleagues, is to start with structural design. And it doesn't matter if you fulfill your 3 years of internship and working through the exam, but you can at least experience the structural design procedure and trying to understand what are the key factors through the design procedure and what is more important and what is not so much important. And so you can take better decisions while you work as a construction manager or as a construction engineer. And the design procedure, I think through design management is very important as well, because you can walk through the process from the first architectural scheme and the first design through the basic concept of the structural solution, all the way through the mechanicals and the MEPs and the interior design, which are the last procedure through the project design. So I think it would be better if we will start as a structural engineer, and along the road, and you will go for execution and management. This is the right way, I think.
Yeah. Yeah, and it continues this question with, or should I specialize in one and stick to it?
That's also a possibility. You can reach out later on, and I will happy to help.
Yeah, I'm actually not a structural engineer. I'm a chemist, but I had started working for a concrete laboratory, and then so I specialized in the composition of the concrete, and then went on to the execution of concrete. And now I am sort of specialized within concrete technology with regards to theory and also practice. So it's sort of a specialized one, but you always have to be able to move somewhat in some direction, in my mind.
I think that the cement industry and the concrete industry and the technology nowadays are almost near to magic, because you can reach some very high strength. And in the Sarona Tower, the one that is like a crossed, I think the base foundation and the base columns are around 100 megapascal. And through Israel, there's a vast majority of structures which been casted with steel fibers and some polymer fibers through and through, just to make the resistance of the concrete to work for 50 years and 75 and 100 years. There's a special project in Israel, we call it the Baha'i project, through the Baha'i religion, which originally was designed for 500 years. And over there, it was a pretty high-tech concrete.
Yeah. I guess you don't have any frost in Israel?
Not so much, only in the north, and only 2, 3, or 4 winters in Jerusalem also. I'm from Jerusalem, so we are happy to have snow, but not so much.
But when you define a concrete, do you define both the strength and durability class, or just go with strength?
And there's the strength class and the durability class of exposure in Israel. If it's if it's near the soil, or is it exposed to the elements, or is it just in a regular interior concrete? And there's some specifications about it. And in the south, there are some corrosive sand and soil. So there needs to be a much more higher cement in the mixture, and some regulations about the cover of the reinforcement.
Yeah, same in Norway, but we have a lot more of chlorides, I guess, and then also frost, which it usually is the limiting factor for a concrete. A question from Arlie. I'm currently taking a construction engineering and management. I just want to know what are the common risks that you have encountered in your projects and how do you manage that problem and deliver the project successfully?
That's a great question, because I think management-wise, the thing that I've been dealing with, and most probably you will gonna be dealing with also, is the amount of changes throughout the project procedure and project design. And you need to understand that sometimes the destiny of the project or the function of the structure not always goes along with the architectural design and the architectural concept, and changes needs to be made. But it's really important to try and clarify it as soon as possible, because once you are working the problem and trying to figure out a structural solution, and in some way, it doesn't matter, and getting all along changes through the main program, through the main voids, and shifting voids, shifting the procedure, shifting the fluidity of the structure will definitely change the solution, the structural solution. You can say it's only columns and slabs and beams and etc., and it doesn't really matter. But when you're dealing with massive projects and massive structures, every destination, every calling of the space, every function of the space is limiting and actually guiding you to the best solution of this specific project. And while changes needs to be made and keep on coming, it's really hard to know that you are handing over the best design that you can, because you keep on dealing with the changes all along. So it's like a spectrum where you need to hand over the programs and everything on time, while you may be sometimes sacrificing the best solution for the project.
Yeah. For those of you that don't know much about the FIB and the Young Members Group, I'm sending you the link in the chat now, where you can go in and read more about the Young Members Group, and you can also press a button on that webpage, get in touch, and then you will be able to get into our sort of closed area where we put some documents. You can also ask questions and have discussions. So I encourage you to join that. Joining that group is free, and of course, joining the Young Members Group is also free. But we encourage our young members to join the FIB, which is our mother organization. And for us young members, it's half of the price compared to regular paying members. So I think it's 80 euros for 1 year, and then you get access to a lot of important documents that the FIB has made. Question from Ahmad Khartabil. What is usually the targeted service life for the structures you got involved in, and what kind of measures are considered to ensure this service life?
So in Israel, most common structures are designed to last for 50 years. Some of them in special regulations, or like special structures like hospitals and power plants and stuff like that. Needs to held around 100 years or maybe 150 years. And it's mostly restricted to the concrete design and the covering and the cover layer of concrete on top of the reinforcement, and some other regulations relating to the soil and structure interaction, which need to be held through the entire project, and to make sure that the structure will act ductile wise and throughout the future earthquakes to come.
Good.
Ahmad, I think, is
almost the
the
same in Norway
Emirates
as well.
representative. Ahmad Khartabil is I think it's the Emirate representative of YMG.
Yes.
Happy to have you here, Ahmad.
Yeah. You were at the same introduction meeting with the Young Members Group Board.
Yep.
So for those of you don't know, that the Young Members Group internationally has recently gotten in touch with the Young Members Group in Israel, and also now a new one in United Arab Emirates.
Which is great.
Yeah.
I'm happy.
I'm very impressed of all the work that you have done.
Thank you.
Another question. Can you please give an example of value engineering process and how you normally manage the process alongside the entrepreneur, architect, and project manager?
Yeah,
Entrepreneur is a contractor.
sure.
In English, yeah.
I think I had an example a couple of years ago where a commerce and an elderly inhabited structure was designed, and there was a swimming pool in the lower floor. It wasn't really a basement because it was half open to the surface. But on top of this, on top of the ceiling of this floor, on top of the slab, there was the accommodations. And on top of the pool, there were two main columns. That one of them was outside of the pool, and one of them happens to be inside the pool. So while we were doing the alternations and the static schemes of this entire structure, and everyone was a bit overwhelmed, and that in my schemes there was inside the pool, and everyone said no, it can't be done because it's not going to work. And I said, okay, do you want to listen that for the other alternative is that we will shift the entire solution for the 6 stories above, and we will change the direction, or we will do like a transfer beam, so it will carry out the 450-ton load of service throughout the procedure. And walking through this process and showcasing that the more complex solution will be much more expensive. The difference between these two solutions, that one of them will lower the column down through the pool, and the other way around with a transfer beam, and doing the alternate static scheme for the 6 floors above, and the difference was around 12 million shekels, which is give or take 3 million euros. And so everyone knew that it's not going to happen. And now there's a column wrapped in concrete inside the pool. So I think this value, where at the beginning, no one actually thought it could be done, and not in concept-wise and not through the architectural process, and especially in the interior design. And the entrepreneurs of this project was pretty happy that we thought about it, because the project actually took place and went for execution, and it was a pretty awesome project.
Yeah, good. And that is also one of the things that makes civil engineering or structural engineering, working with concrete, building materials, working for contractors. You always have to find up some new solutions and use your brain to figure out the best solution. So there's not always one given answer. You also always have to think ahead and think about all the surroundings, all the materials being used, costs, how much time you have. So you always are continuing to learn new things and to develop for the better. That's one thing that makes it very exciting to work with.
Yeah, I agree, totally.
Okay. If there's no new questions now, I don't think so, then I want to thank you, Ze'ev.
Thank you very much. It was a pleasure.
and can't remember the name now. I think he
Shahar.
left.
Shahar.
Yeah. For the presentation and introducing yourself to the rest of the international environment. We welcome you and look forward to hearing more from you and cooperating in the future. Yes.
It's very mutual. Thank you very much, and come to Israel if you can, and we would be more than happy to show you around, show you some very interesting projects, and reach out to all of you guys. Hope you stay safe during this COVID pandemic, and thank you very much for inviting me. Thank you.
Thank you. Thank you very much. And thank you for all the participants. And hopefully we will get this video up on YouTube if you want to share with friends or family.
Great.
Or colleagues maybe over the next few days.